Section 9.4, the product rule. So this is where you've got two functions that are multiplied together. You need to memorize the rule. The derivative of those of the product of two functions is just a combination of the individual derivatives and the functions. So memorize this as vu dash plus uv dash, where u and v is the product that you are dealing with. I want you to memorize it in this order, so keeping your v's on the outside, because that will help you with the next rule, which is called the quotient rule. Okay, so just going to, in every example where you have to apply it, quote it. So, and you need to obviously identify for yourself that this is the product that you are differentiating. So here we've been asked to differentiate this function. It's clearly a product of two functions. So always set it out in this way. So it's u equals to x squared and v next to it. And this is, I'll prepare it for differentiation 3x minus 1 to the power of a half. U dash can be found straight away. We're going to write it as 2x, and v dash. So here we're going to apply a quick chain rule. So remember what we said, you've got something here to the power of a half. So the power comes down, it's a half. That something needs to be now given the power of 1 less than a half. So minus a half, and follow it by the red bit differentiated, so it's 3. So I'll write it a bit in a different way. 3 over 2, 3x minus 1 to the power of minus a half. Now quote the product rule. So uv dash is going to be vu dash plus uv dash. You might say, well, it doesn't matter which way around we multiply, vu dash or u dash v. It doesn't matter, but it just helps us with memorizing it, especially with the quotient rule. So we just need to combine these diagonals. So there you go. So we're going to do vu dash first. So it's going to be, I'm going to actually put 2x times that. Plus uv dash. So over here I've got 3 over 2 x, 3x minus 1 to the power minus a half times x squared. You may want to put them like already in a nice orderly fashion, so put 3 over 2 x squared times 3x minus 1 to the power of minus a half if you wish to do it straight away. Okay, so we're going to combine these now into one fraction. Okay, so over here we've got 2x times square root of 3x minus 1 plus, let's send this into the denominator. You will have 3 and x squared in the numerator, because remember x squared is x squared over 1. In the denominator you will have 2, and this one will be 3x minus 1 to the power of a half, so 3x minus 1 square rooted. We're going to combine these, so treat this as a fraction. So you need to, common denominator is 2 times 3x root 3x minus 1. So you times the top by 2 times 3x minus 1. Okay, let's continue. Okay, I know I've got an example here, but I'll have to do it separately. So over here we are going to have 2x times 2, so it's 4x. And then 3x minus 1 square rooted times 3x minus 1 square rooted, it gives me 3x minus 1. And then plus 3x squared over 2, and then the square root of 3x minus 1. Okay, so over here we times these together, you'll have 12x squared plus 3x squared. So that's going to be 15x squared, and then minus 4x over 2, and then 3x minus 1. And lastly, maybe factorize that x to get 15x minus 4 over 2 square root of 3x minus 1. That's our differential. Okay, so we've got a function y equals e to the power 4x sine squared 3x. I need to show that the derivative of this function can be expressed as the product of e to the power 4x sine 3x, and the bracket is shown. We need to find what value of a and b is. So you can see that this is the product rule. We're going to call the first function u, so e to the power 4x. The next function v, that's sine 3x. Let me write it like this, squared. Okay, u dash is going to be 4e to the power 4x, and v dash, so here we've got the inside function to the power of 2, so it goes to, if I know that u squared goes to 2u, so this one will go to 2 lots of sine 3x, and then followed by this differentiated, so sine 3x, sine goes to cos, but it's times by 3 because it's 3x, so 3 cos 3x, there you go. So it's multiplied by 3 cos 3x. Tidy it up further is 6 sine 3x cos 3x. Splendid. Okay, so what do we need to do here? Quote the product rule. So it's vu dash plus uv dash. And let's find dy dx. So vu dash, the product of this diagonal. So I'm going to put it the e's in front. So it's 4e to the power 4x, and then sine 3x squared. I'll write it like this first. Plus, let's combine these together. So you've got 6, and then you've got e. So let's put them in order. 6e to the power 4x. We've got sine 3x once, and then cos 3x. Okay, we've got to factorize the common factors, where 2 would come out as well, but they don't want us to because they want to have no constant in front. So e to the power 4x can come out. Let's just lightly cross it off, or as we've used it. Slightly, don't cross it off with pencil if you're doing it in exam. And then you've got sine 3x, so we're going to use 1 sine 3x, and then we'll use 1 from here, so you will have 1 left over. And inside the big bracket you'll have 4 left from the first term, and 1 of the sine 3x, plus 6, and then cos 3x. Really, you should take 4 and common factor 4 and 6 out as well. So a is equal, actually should have written it the other way around, as long as I state these, and b is equal to 4, because a was coefficient of cos and b is coefficient of sine.